So welcome back. Today we are continuing with the portions of Java, and so far we have been looking into the overview of Java language, and right now we'll be starting off with some fresh topics. So some of the topics being discussed here have already been explained to you via the programming examples that we have already seen in respect to Java. So we have seen the concepts of class definition, how we saw it over there, and we saw that a program can have a single class minimum. It should have a single class, and there can be multiple classes within a program. We have seen that. Now, the number of classes can vary with respect to the complexity of the program. There should be a main method class which contains a main program, and all those details can be read over here. Then we looked into the concept of object, and then the classes, the basic definition, and all are given over here as per the slide. In the next slide, we are going to learn about different kinds of variables that come into role in Java programming. So the first concept is that of a local variable. So local variables are those that are declared in a method, constructor, and the classes or the blocks. Now, a local variable, when created, it is destroyed once it exits that particular method, constructor, or class, or its relevance is sticking on to the entity in which it is created. Access modifiers cannot be used for local variables. A local variable will be visible only within the declared method. So if we look at this a particular example over here, we have this example over here. Here, age is the local variable. So you can see this concept over here. You have a public class called test. It has got a function called pubpage, and it is executing a certain function where you have a variable called age 0, and that age is incremented to 7, and the display will be happening over there, the puppy ages plus age, where you will be displaying the age of the puppy, and then you have this main function over here where you're creating an object which is called test, and you have a constructor running over here, and then this test will be calling the function pup age, and it will run this function and display the value of the variable age. Now if you look over here, this age is a variable that sticks within the function, and it is not being called or used anywhere else. So that is the meaning of a local variable. Now, an instance variable is a different concept. An instance variable is a variable that is bound to the object itself. It is declared inside the class, not inside a function. So in the previous case, you had seen that this age is a variable that is declared within this function called pubpage. But here it is declared within the class, which means any function can use it, or rather it means that any object that is belonging to this class can access this instant variable. So like what we had learned in C++, you have some instance variable, then each object will get its own respective copy of that instance variable. So we'll look at with the example of a program, and you can read this text to understand its particular meaning. The next set of variable is called class variable. Now, class variables are usually the ones that are declared with a keyword called static. See, most of the concepts that we had learned in C++ is applicable in Java also. Hence, we are learning this concept of object-oriented programming in C++. But when it comes to these Java, some aspects of the functionality or naming might change. Apart from that, almost all the concepts are similar. So we have already looked into this case of a local variable, and we have already looked into the case of this instance variable where we had created or we had seen via a program that every variable created will have its own copy when an object is being created, or rather an object will have each of its own variable copies for operating upon. Now you had looked into the static variable concept also. So when we look into the static variable, what was the concept over there? That means only one copy of the variable will be retained, and all the objects will be accessing the same variable. So here class variables are basically the static variables, and we'll look into the program to see an idea about it. Okay, so now I will explain each of these variables with the help of a program. So here basically you have the same program over here about that pub page. So here you had a class called test, you had a function called pub page, and inside that you had a variable age equal to 0, and this age would have been incremented to 7 with this condition over here, and you're displaying the puppy's ages, the value. And you have created an object over here. The new test constructor is run, it is calling the function, and its function will be executed, and you can see that the puppy age is 7, it is displayed. Now what it means is that this variable, the local variable, is able to function within the class, and it is able to execute the variable within the function. Now I'm editing the statement over here. I'm going to add a particular command over here, test.age. That means my object is trying to access this variable age and make it 17, and when I try executing this program, it displays the error. It cannot find the symbol test.age equal to 17. That means it happens because of the conflict within the local variable and the object concept. So an object will not be able to access the local variable. But how can you edit this program? If I want to edit it, I have to modify this one particular program. So I will add another statement over here. I am going to add a new variable in age1. So now this age1 variable is not a local variable, but it is an instance variable. That means it is created within the class. It is not defined in the function. So age1 is an instance variable, and it can be accessed by any object. So its access is not restricted within a function, but it can be accessed by any object that is created within the class. So I'm modifying this function also. So let this function be here, not an issue. So I'm creating a duplicate version of this function. I'm going to name it as age1, and I'm commenting these two statements. I don't need this. So I'm commenting these statements. Int age is equal to 7. I don't need this also. I'm going to change this as puppy's ages plus age1, displaying it. So now what I do here is I am going to set or access my instance variable age1 with the object. I'm going to set it to value 17, and I'm going to call the function here, which is again this command, and I'm going to place it over here, and this function will be page1. And when I try running this program, so I hope you got the concept. You have a local variable over here, which is age. This age1 is an instance variable which is outside a function but within the class, which means its scopes lies within the class and any object that creates it. I've created a new function page1 here, and it will be accessing the variable age1, and it will be displaying the function. Moreover, you have a statement over here where this test, that is an object, is trying to access this variable age1. So when I try running this program, and you can see that when it gets executed, you can see that both the functions have been executed without any error, which means this object test has been able to accept or access the instance variable age1 and set it to 17, and page1 has been called, and it is able to display this statement, page is 17. So I hope you got the idea of a class, a local variable and an instance variable. The class variable or the static variable in this Java programming. So you have a public class here. We will have an issue because p should have been small. Only then it is identified as a keyword, and this public class main exists over there, and then you have a static int count which is declared over there. Now the static variable count is declared as static. You have the function increment over here, count plus plus, and then when you have the object being created, obj1 is being created and obj2 is being created, and then obj1 is calling increment this function whereby count will be incremented and object 2 will be incrementing the value once again, and you'll be displaying the corresponding count values. Now, since it is declared as static, what does our old concept of static mean? If a variable is declared as static, all objects will not get its own individual copies, but rather there will be only one copy of the variable called count over here. So when I actually run this program, so let us look into the logic. Now the count is initialized to 0, which means count is maintained with the value 0, and there is only one copy of it. So now when obj1 calls the function increment, what happens? Count will be incremented, so it will become 1. Now obj2 is again calling the function increment, which means since it is static, count, since it is 1, it will be incremented to 2. Now this particular obj is calling this value obj1.count. So what would be the value? 2. This obj2 is also calling the variable count. So what would be its value? 2. So when we execute this, we can see that the count is 2 and 2. Let us see the difference over here when it is not declared as static. So this is not declared static, which means it is like any other instance variable. And when we do, so if it is any instance variable, what does it mean? Each object which will get its own count. So when obj1 calls increment, obj1's count becomes 1. So count will become 1. What will happen when we call this obj2 dot increment? Obj2 has its own count, which will become 1. I hope that concept is clear of the static variable. When we run this program, you can see that the answer is same. Obj1 is 1 and obj2 count is also 1. So I hope that concept is clear. You can take a look at this program also. So here we have a class called employee. This class is there, which is called employee. You have an instance variable called name over here, which is of data type string, and it can be given an access specifier, which is again something that we had discussed when we learned about local variables. Local variables will not be given any access specifier. So here it can be specified with access specifier, and now you can see that the salary value is private and this is public. Now you have a function being called over here. So employee, you have a constructor essentially, because how do you identify a constructor? You have a constructor called class called employee over here. So here a function is there with the same name as that of class, which makes it a constructor, where you have this emp name, and name will be stored with the value that is passed, that is emp name. Now the value, you have a function set salary, where you have an argument also emp sal, so salary will be equal to emp sal. You have the print emp function where you'll be displaying the name as well as salary. So when we create an object, now since this is a constructor, you have to identify a difference over here. This is a constructor, so it should be accepting the name. Now this is a one constructor that is defined. So in the main function, you have a object being created, that is emp1, and you're running a constructor passing the name Ransika. So that is the emp name, which is in string. And then you're having the setting salary, which is passing a value 1000, and print emp details, where you'll be printing these details. So when we try running this particular program, you can see that it has been displayed Ransika, and the value 1000 has been displayed as salary. So in this particular video, we had learned about some basic concepts about variables. We discussed about what are the different kinds of variables that are being used. We looked into local variables, we looked into instance variables, and we looked into static or class variables. So these are the three kinds of variables that come into relevance in Java programming, and I hope the concepts are clear.